the average cost of daycare in 2001 was $516, and the cost is increased by $1,775 per year. Okay, and the cost is based on a 3-year-old attending 8 hours a day, 5 days a week. Okay, so I want to first find the slope of the linear model, and now the slope is actually written for me right here. And again, that per year, that $sign per year indicator with that ratio of dollars per year tells me that this is the slope. So I'm looking for that for that ratio right here. So the slope is 17.75, and again, what does it mean? It just means that's many dollars per year. So what does it mean? I'm just going to say my units. So I'm not going to write them down right now, but dollars per year. Now find the equation of the model. Okay, so y equals slope 1775 times x plus b, and b is my initial or starting condition, my y value, my y-intercept value, and so that's going to be my 516 for this example. Okay, so predict the average monthly cost in 2011. So what I need to know first is how many years has it been. Now notice we were starting in 2001. 2001 was my intercept value. So right now in 2010 or 11, it's been 10 years. Right? So 10 years. Okay, so my answer is going to be, well, whatever, y equals 17.75 times 10 plus 516. Okay. So I know that 17.75 times 10 is 7, let's see, like that, 177.5 plus 516. So I know I get, let's see, 0.5, 13, carry the 1, 8, 9, 6. Okay, so the average monthly cost in 2011, I'll put my $sign on there, it's going to be $693.50. Right? Okay. So this one is very similar. I think I'm going to skip number 18. What's the slope? Well, this is the slope. And what does the slope mean? Well, it's oil refineries in T years, so it's the oil refineries per year that we've increased. What's the n-intercept? Well, that number right there. What does it mean? That's the number of oil refineries in our 2004 year. And then when I want to do t equals 17, we're just going to plug in, it was 2004, so if we subtract off 2004, that's going to be 13 years. So we're going to plug in t equals 13 years and just simplify. So I'm going to skip on that one and talk about the next one. So in the next one, we've got a system of 2 equations, and we want to determine without solving whether the system has 1, no solutions or infinitely many solutions. Okay. Now I'm going to do that by talking about the slope. So I'm going to solve each of these equations for y. Okay. So in 3x equals 2y minus 4, if I want to get y by itself, I'm going to add that 4 over. Okay, so 3x plus 4 equals 2y. If I divide everything by 2, that gives me 3/2 y plus 2, 3/2 x, my bad. I don't know why I put a y there. Equals y. There's my y. Alright, and if I look at the other one, solve this equation for y, 4y minus 6x equals 8, and we're going to add that 6x over so we can get the y by itself. Okay, 4y equals 6x plus 8, divide by 4, divide by 4, divide by 4. In this one, y equals 3/2 x plus 2. Okay, notice that these 2 equations are identical, or an identity. Since they're an identity, the answer for this one is infinitely many solutions. Infinite many solutions is our answer here. Okay, now what would you have done if instead this was like 7 or something? If it were 7, then we would say there's no solution because they're parallel. They have the same slope, but they have different y-intercepts. Okay, and if we change this other line here altogether, what if we say that this one is now, for example, y equals 4/5 x plus 2. Now this one has a different slope than this one, so that would be what it would be if I had exactly one solution. So it's just whether or not they're identical, parallel, or just two different lines. Okay, so this one was infinite because the lines were identical, or an identity. Okay, solve this system using each of the following methods. I'm going to solve it using addition, substitution, and I'm going to graph it. I'm going to get the same answer for all 3 times. Alright, so first of all, I'm going to do the addition method. For the addition method, I'm looking at my x's and my y's and trying to decide what the least common multiple is. For the x's, it would be 6. 2 and 3 both go into 6. For the y's, it would be 2. 1 and 2 both go into 2. Okay? Usually I just pick the one that has the smaller LCM, so I'm going to use my least common multiple of 2 right here instead of the 6. I'm erasing everything I don't want to erase. I'll go back and rewrite that. I'm going to use these 2 because the LCM is 6. Or 2. LCM is 2 here. I didn't want 6. Okay, so what I'm thinking about is I really need to make sure I get 1, 2, and 1, -2. This one's already got a lovely -2. So I want to make sure I can get this one to be +2. To get that, I'm going to multiply this entire equation by +2. Okay, so that top equation becomes 2 times 2 is 4x plus 2y equals -14. Now I don't change this equation because I already had what I want. So I've got 3x minus 2y equals -7. Add these guys up. 7x. When I add 2y and -2y, they cancel. Equals -21. Divide by 7. So my x is equal to -3. Only half done with that, right? Because I need to find the y value. So I'm just going to plug -3 in for x in either of those equations. Let's just say the top one. So 2 times -3 plus y equals -7. So that's -6 plus y equals -7. Add 6. Add 6. Y equals -1. So my answer is the ordered pair -3, -1. Alright. Now, we're going to get the exact same thing using substitution. Okay, so I'm going to use substitution now. I'm going to erase right here because I'm going to talk about what I need to do for substitution. For substitution, I want to think about which of these variables is easiest to solve for. Now, I would have to divide by 2, divide by 3. This one right here is perfect because it has no number that I have to divide by. It's just got a coefficient of 1. So I'm going to solve for that y. So 2x plus y equals -7, and I'm just going to subtract this 2x off of both sides. This gives me y equals -2x minus 7. Okay, so what we're going to do now is say this is what y is equal to, and in my other equation, that's where my y is. I'm going to replace the letter y with what y is equal to. So that bottom equation becomes 3x minus 2 times -2x minus 7. Okay? Equals -7. Alright, so we've got 3x plus 4x, negative makes positive, plus 14 equals -7. So far I've got 7x, mom plus 14, equals negative 7. And if I subtract 14 from both sides, writing a little bit too small right here, let me move down for some more room. I get 7x equals negative 7 minus 14 is negative 21. Divide both sides by 7. X equals negative 3. Now, we already knew it was going to be negative 3 because we solved it over here, but that's what we got. Okay? And y is supposed to equal negative 2x minus 7. So my y value is going to be negative 2 times negative 3 minus 7. I need to pick up my hands more. So y equals 6 minus 7, or negative 1. So my answer is negative 3 for the x, negative 1 for the y. Alright, I got the same answer once using the addition method and once using the substitution method. So this equation was set up very well to use either method. Okay. Now I want to do it by graphing to really see what this answer is. Okay. To use graphing, I need to solve for y in both equations. Okay, so I've already solved for y in the top equation, so I'm just not going to do that again. I'm going to use this right here. Y is solved for. So in one of the equations, y equals negative 2x plus 7. I'm going to need to solve for y in the other equation. So in the other equation, we knew that, I'll write it down here, 3x minus 2y equals negative 7. So subtract 3x from both sides. Okay. So it's going to be negative 2y equals negative 3x minus 7. Divide by negative 2, negative 2, negative 2. And in this one, y equals 3 halves x plus 7 halves. Okay, so let's go ahead and graph the top line first. Okay, so this one was negative 7 was the intercept, and negative 2 was the slope. So 1, 2, 3, 4, 5, 6, 7. And the slope was negative 2, so down 2 over 1, down 2 over 1, or up 2, back 1, up 2, back 1, etc. I'm going to connect those with a blue thing. Awesome. Okay. Looks like that's my line. And this one, that's going to be harder to graph with that 7 halves. So let's try finding a different ordered pair. Let's try using x equals 1. Okay, so if x equals 1, that would give us y equals 3 halves times 1, 3 halves, plus 7 halves. 3 plus 7 is 10, so 10 halves is 5. So I can start at the ordered pair 1, 5, and then use my slope. Okay, so the ordered pair 1, 5, 1, 2, 3, 4, 5 would be right here, and then my slope was 3 halves. So up 3 over 2. Up 3 over 2, or down 3, back 2. Down 3, back 2. Down 3, back 2. Alright, and let's connect those in this lovely green. Okay, and I can see that the intersection point, where these two lines cross, is the ordered pair negative 3, negative 1. Okay, so I got that same answer, and I did the problem 3 times and in 3 different ways, by using the addition method, by using the substitution method, and by graphing it.